Welcome to next session. So next problem is, see, a pair of carefully cut spurgates. So in the question they given that carefully cut spurgates with 20-degree full depth involute profile is used to transmit 10 kilowatt power at 200 revolutions per minute of the pinion. So they have given alpha, they have given power to be transmitted and the speed of the pinion. Next, the gear has to rotate 300 revolutions per minute. So the gear is rotating at a speed of 300. The material used for both pinion and gear is medium carbon steel whose allowable bending stress may be taken as 230 MPa. So they told that, so the both the pinion and gear is made up of same material, that is nothing but medium carbon steel, and the allowable bending stress is 230 MPa. Determine module face width of this spurgear and pinion. Suggest suitable hardness. Take Z24 teeth on the pinion. Modulus of elasticity may be taken as 210 GPa. So we are going to find out M, we are going to find out B, and we are going to find out the hardness of the gears by using the data. So they already, I told that they have given alpha, they have given power, speed of the pinion, speed of the gear, allowable stress sigma naught 1 for pinion, sigma naught 2 for gear is same. Z1 they given in the question. Young's modulus they given E1 and E2, that is Young's modulus for the gear and Young's modulus for the pinion. So they given in GPa, we are converted into Newton per mm square, and they told that carefully cut spurring. So by seeing this data, first we have to see whether they given N1, N2, Z1, Z2 or I. So in the question they have given N1 and N2, so no need of finding. Z1 they have given, but they are not given Z2. So by using the relation, same thing, velocity ratio I is equal to N1 by N2 is equal to Z2 by Z1 is equal to D2 by D1. We are going to calculate Z2. So take this relation N1 by N2 is equal to Z2 by Z2, that is N1 by N2 is equal to Z2 by Z1. We can able to calculate Z2. After calculating Z2, then we are going to find out Levy's form factor Y. Since here they given 20-degree full depth, so for 20-degree full depth, this is the formula to calculate Y. So from this equation number, so to calculate Y1, substitute Z1. To calculate Y2, substitute Z2. We will get Y1 and Y2. Now we are going to find out first step, that is nothing but weaker member. So already I told that if gear and pinion is made up of same material, then directly we can take pinion is the weaker member. Always remember, again no need of finding. So here in the question they told that both the gears are pinion is made up of same material, that is medium carbon steel. So sigma naught 1 is equal to sigma naught 2 is equal to 230. So directly we can take, as pinion and gear is made up of same material, pinion is the weaker member, therefore design should be based on pinion. This sentence you have to write in the first step, that is nothing but identify the weaker member. Based on this weaker member only you are going to design. If you made any mistake here, then remaining complete we will get wrong answer. Sure. So after finding weaker member, next step is remaining same procedure up to the module. So next step is tangential tooth load. So already I told that the formula is Ft is equal to 9550 into 1000 into N into CS divided by N into R. Since we got pinion is the weaker, so therefore Ft1, N1, R1. And sure. So same thing, service load factor CS is equal to 1.5 and R1 is D1 divided by 2, and we are converting diameter in the form of module into Z. We will get 12 into M. Substitute everything, we will get some value divided by M. Give this equation number 1. As same procedure as previous problem. Next we are going to consider Levy's equation, that is nothing but Ft is equal to sigma naught Byp into Cv or Kv. Now we got pinion is the weaker, then we will get sigma naught 1 and Y1. So already sigma naught 1 we know, and this is nothing but ft1. B is nothing but B is equal to 10 into module, P is equal to pi into m. So in sigma naught 1 given, so substitute everything. Sigma naught 1, B is 10 into m, and the value of y1 pi into m, keep kb as it is, we will get 838.177 m square kv. Since we are having m here, we are having m here, m square kv. So this gives this equation number 2. Equating equation 1 and equation 2, we will get m cube kv is equal to 14.24. So now calculate velocity. V is equal to pi d1 n1 divided by 60,000. So again convert d1 in the form of m into z1. Calculate, we will get 1.508 meter per second. Now same procedure. First trial 1. Select module is equal to 3. Instead of selecting 3 directly, you can select 2 also, no problem. So in closer way we are going to calculate. You can select 2 or you can select 3. And sure, if I am selecting 3, so substitute 3 here. So then velocity will get 4.5. Again velocity 4.5 is less than 7.5. Again the formula will be same, 3 divided by 3 plus Vm. So we will get Cv. Now substitute this Cv, that is nothing but Kv. In this equation I will give, this is equation number 3. In equation 3, so in equation 3 we are considered directly m is equal to 3, and Kv is nothing but 0.310. So we will get 10 point. Since 10 point is less than 14.2, hence it is not suitable. And so again we are going to for next trial. Again we have to go for next trial. Again we are going to go for next step. Again here they have selected module is equal to 4. So if you select module is equal to 4, we will get velocity is 6.08 and kv. Again substitute velocity and kv in equation 3. So we will get here 14, that is 21.248. Now it is greater than 14.242, hence it is suitable. Therefore module is equal to 4. Once you get module, B is equal to 10 into m, that is 10 into 4, that is equal to 40 mm. Now module is over, phase width is over. Now we have to check whether the calculated module and the phase width is right or wrong. Then for check for the stress, same procedure as previous. Allowable stress is equal to sigma naught 1 into kv, sigma naught 1 kv substitute. Again induced stress is equal to ft divided by b by p. So we will get induced stress. Now we can see allowable stress and induced stress. Always the induced stress should be less than the allowable stress, then the design is safe. So therefore induced stress is less than the allowable stress, hence the design is safe. And sure. So then directly we will go to the dynamic load. So dynamic load is the formula already I told that this dynamic load will get due to some errors in the beginning session I told. This is the formula. By using this you will calculate. Here Ft is nothing but Ft1. See how to calculate after you are calculating module. So from the equation 1 you are going to calculate that. See from equation 1 you are having 11937.5 divided by m. Substitute m here, you will get Ft. That Ft you have to substitute here. Understood? So Ft you will get, already Vm you have calculated. So this is nothing but for which one you will get the module, that velocity you are going to consider. Next, B phase width you know, only unknown is C. That is, we are going to calculate C. This C can be calculated by using the table. So by using this table 23.32 we are going to calculate C. So before calculating C, first we have to calculate error F. So this error F can be calculated by using the figure 23.34a. From this figure, based upon the carefully cut gauge, see this they are given in the question. So by using this, and by using this and by using the module, see we will get like this figure. Like this figure we will get some curves you are having. So this curve is nothing but carefully cut gauge, something 3-4 curves you will get. So here we will get module and here we will get F. So by taking module is equal to for and selecting which curve we are having, that is carefully cut gear, and we are going to come like this, and we are going to calculate the error here, F here. So for that we are getting 0.25. After calculating this, then we are going to move for the table. For in this table, based upon the F, whatever the value will get F, and based upon the alpha they given, we are going to select the C. And also we are going to see the material for pinion and gear. See here they told that both the pinion and gear is made up of carbon steel, right? So that is, gear is also made up of steel, pinion is also made up of steel. Therefore error F, alpha, and steel pinion, steel gear. And so based upon these three things, by taking F, by taking alpha, by considering the pinion and gear material, we are going to calculate F. So we will get Fc is equal to 290 kilonewton per meter. So after calculating K, substitute everything, finally we will get D is equal to 10450.6 Newton. Substituting the value of Ft, the value of Vm, B, C, everything, after simplify, we will get Fd is equal to this value. And sure. Next, after calculating Fd, then we are considering the wear load. So wear load is the formula Fw is equal to D1BQK, that is D1BQK. Here always it is D1. It may be pinion or weaker, gear may be weaker, always we have to consider D1 only. So as you know that D1 is equal to M into Z1. You already know M, you know Z, you can calculate D1. B you know, but unknown is Q and K. So the formula to calculate Q is equal to 2 into Z2 divided by Z1 plus Z2. Here also this is constant, always you have to take Z2 divided by Z1 plus Z2 only, and this is the formula to calculate K, that is 1.43 sigma square, sigma 1 square sin alpha divided by E naught. Or we can take it as 1.43 sigma square F sin alpha divided by E naught. Here we are going to calculate E naught by using the formula E naught is equal to 2 into E1 E2 divided by E1 plus E2. E1 E2 they given in the question, so we will get finally 210 into 10 to the power of 3 we will get. And sure, now taking for safe design, Fw should be greater than or equal to dynamic load. Substitute the value formula of Fw, D1BQK greater than or equal to Fd value. Substitute the value of D1, substitute the value of B, substitute the value of Q, keep K as it is. Y means, since we don't know here sigma F, so we are calculating K. So K will get finally greater than or equal to 1.7. Now you take the formula for K. Formula for K is, this is the formula. So from equation this you will get. So substitute here, sig 1.3 value greater than or equal to, calculate sigma F. Now based upon the sigma F you got, so from the table, see this is the table number 23.37b. For alpha is equal to 20 degree full depth, and sure K is greater than 1.701 and sigma F is greater than or equal to 8.5. Based upon these three things, and sure we are going to find out hardness of the pinion, hardness of the gear. We will get 400 and 300. And sure, so up to here we have to find out, based on, we can find hardness by using the K or by using the sigma F. So finally we will get hardness of the pinion is 400, hardness of the gear is 300. And sure, so up to here we have to find out, this is for 16 to 20 marks. And sure, remaining also same procedure, only different values will be changed or different things. And sure.